Okay, and then we have already discussed about the step response, how to sketch the step response, how to estimate the parameters of a second order system based on the features of the step response if we have an underdamped case. Now I want to just have a quick look on how the impulse response of an underdamped second order system will be. So impulse response, what does it mean by impulse response? Impulse response, of course, is an output of a system when we give an impulse input. Okay, so in our case here, again, we consider an undamped second order system. The input to our system here is impulse. Impulse in Laplace domain, if you refer to the Laplace table, impulse in Laplace domain is 1 in Laplace domain. So if the transfer function of your system is Gs, your response, the output of the system, obviously will be equal to input times the transfer function 1 times Gs, which is obviously is also Gs. Okay, that's why sometimes we say that unit impulse response will tell us the natural characteristics of the system, because the response of this of a system with a unit impulse input is basically in Laplace domain is the transfer function of the system itself. The response is equal to the transfer function. So in a case of let's consider again a case of an undamped second order system with a DC gain equal to 1. DC gain is equal to 1, so our K here is 1, right? So our transfer function, our Gs will be like this. The response, the output in Laplace domain will also be equal to Gs. Okay, this one. If you plot it, the response, the output, the unit impulse output of this system will look like in the right hand side here. So depending on the damping ratio, depending on the zeta of your system, if you have an underdamped second order system, the response is oscillating. But of course in here your since we have an underdamped system, so the response is oscillating, but the amplitude is getting smaller and smaller. The smaller the damping ratio, the smaller the zeta, of course, the more the oscillation in your response there. Right? The steady state response of this unit impulse response will be equal to 0. Okay, so the steady state value will be 0. So there is typically the behavior of an underdamped second order system with unit impulse input. From mathematical point of view, this impulse response can also be obtained by differentiating the unit step response. Okay, from mathematical perspective. Okay, for critically damped and overdamped case, of course, you will not have an oscillation. So in that case, the unit impulse response will not oscillate. If it doesn't oscillate, what does it mean? It will remains in one side of the steady state response, of course. If it is positive, then it will remain positive. Okay, if it is negative, it starts from negative, then it will remain negative. If the damping is too high, it will remain 0. Okay, for underdamped case, unit impulse will oscillate around 0, so it will take positive and negative alternatively, but the amplitude will become smaller and smaller until it reach the steady state values, which is equal to 0. To summarize what we have already discussed, we have learned together on how to calculate features of a second order system and the step response. At the last part, we also have analyzed DC gain, undamped natural frequency, and damping ratio of a second order system. Okay, that's all for this session. We meet again in the next topic. Thank you.